Welcome back to Lecture 9 in GRA 6036 for Thursday, March 19. So we're still talking about hypothesis testing, and we are here. So we have formulated a null hypothesis about the possible effect of closing the schools on the number or the share of infected people in the country. So this is our null hypothesis, and this is our alternative hypothesis. So no effect versus some effect. And here we haven't specified whether or not the effect is positive or negative. Well, so it's a so-called two-sided test. Anyways, let's think about the type of when testing such a hypothesis. So when either deciding to keep the null hypothesis, continue believing that closing the schools has no effect, versus rejecting the null hypothesis, which means that, well, closing the schools does have some effect on the share of infected people. Then, well, we can commit to think about the possible the type of errors we might commit. We can draw a 2x2 table. So let's say, well, truth or reality is that either H0, the null hypothesis is true, or the alternative hypothesis is true. And we can make two different decisions. We could either reject the null hypothesis, or we could keep the null hypothesis. So here we have then a 2x2 table. Okay, so if we decide to keep the null hypothesis, when the null hypothesis is true, well, then we're good. Because then we decided what is true. If we reject the null hypothesis, when the alternative hypothesis is true, so that the null hypothesis is false, then we're also good. While if we decide to reject the null hypothesis, when the null hypothesis is true, we commit what's called a type 1 error. So that's bad. If we decide to keep the null hypothesis, so if we decide to continue to believe that school closings has no effect, when indeed school closing does have an effect, then we committed what's called a type 2 error. So of course, what we would ultimately want to do is to control the probabilities of committing these two errors. So we would like to minimize the probability of being either here or here, and maximize the probability of being either here or here. Well, that is not possible. We can only control one of the error probabilities, and the common thing to do is to control the probability of committing a type 1 error. Okay, so remember that I said that in the coin tossing example, now I'll put that up again. In the coin tossing example, we stopped believing the fair coin hypothesis because the probability of the data was so small under this hypothesis. Okay, but that raised the question, well, how small? What is small? Well, this is small, but I mean, we need some threshold to say whether or not something is small. So that threshold is what we call the significance level, and that threshold is basically the probability, or the maximum probability that we allow ourselves of committing a type 1 error. So a typical number for this threshold is 5%. So a typical so typically we want this probability, the probability of rejecting H0 when H0 is true. So this means then this is then the probability of type 1 error to be smaller than some number, let's say alpha, and quite often alpha is set to be 5%. Okay. So now we talked about error probabilities, that we can construct tests where we control the probability of committing a type 1 error. And now we need some means by which to test this hypothesis. And that will lead us to test statistics, which will be the topic of the next video.